just visit Berlin and the two girls. And Joshua. Okay, in the meantime, while we wait for them to come back, could you take out your WA1? Okay. Just want to check the signature. Okay, can. Okay. Sign your WA1. Sign? You're not meet your parents, or because you all forgot?
I tell them my mom doing it. I thought my mother she was like,
Okay. This is all you should remember, of course. Didn't you sign it? So not sign up. You sign it? But it's not. Okay. So I expect the rest of you, right, or most of you in fact, okay, to actually get it signed by next Monday. Okay, that's our next text lesson. Alright? Okay, next. Take out your homework, exercise 3B. Are there any issues regarding the homework? Here's your curve ruler. I hope this is the curve ruler needed. Okay, 3B, any questions regarding question 1D? Am I right? Yeah. Questions for 1D? 1E? Question 3? Question 4? 7? 9. No issues? Okay? Wonderful. Okay, then can you submit your homework to the front? You what? Yes, thank you. So we have to sign your WA1. No. Joshua, have you signed your WA1? No. By end of today, thank you. Huh? PDF? No yet. Most of them also never signed.
It's also disappointed.
Huh?
He's also disappointed in us.
Okay, expect. Homework? Oh. Wait. Oh. Yes, right. Thank you. Question 9. Which part, Chloe? Part 4. Do you agree with the statement that Class A generally perform? What do you think? Can you just give it a try? Okay. I want to see your attempt. Then after when I return, I'll go through. standard deviation. Can? Okay, I hope that you are somewhat familiar with your calculator pressing already. Okay, so yesterday I did not actually go through like how to present the answer. Okay, we only practice using these numbers in order to get the mean mark. Alright, so in this case, okay, to present your answer, okay, you should write the mean is one color. Okay, so this question we're trying to find the mean, yeah? Okay, usually we always write the first two and the last two data. 18 plus 4 plus dot 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 plus 11 plus 20. Because the way for us to find the mean is always to add up all the data and then divide by the total number of data that we have, which is log. Okay, then we get the final answer to be 13. Right? This is also one way that you could end up checking your answers, that and it is actually possible as well, that you just add up everything individually. Okay, 18 plus 4 plus 11 all the way to 20 and then you divide by 12. Okay, so it should give you 13. Alright, just in case, okay, your calculator skill and in remembering what are the steps required, okay, in case it isn't correct, then you could always rely on this formula itself. Okay. Hang on now. Okay, so next, looking at example 20, okay, in example 20 what we have is called a group data. Okay, so this is what we call ungrouped data. And this is what we call group data. It's called group data because looking at the table, what and how we interpret from this table is that there are actually 47 zeros if I were to list it all out. Okay, so this is the frequency because we're looking at the number of children in each of the 300 families. So these are the frequencies and this is the data itself, which is the number of children. So you need to be able to differentiate between the data that you're collecting and the frequency that you're saying. So there are actually 47 zeros if you want to really list it out, okay, which is a very troublesome thing. Okay, so 47 of it. And then after that, if you want to list out all the ones, okay, there will be actually 81 of it. Alright, so essentially this is data, this is frequency. Okay. So right, when it comes to group data, your calculator pressing method will follow this segment in the instructions that I've given you. Okay, so grouped. The difference is in this step whereby you need to switch on, okay, the frequency part. Okay, because if you had done what we did yesterday, you will find that the table for Casio calculator, you only have one column. So one column will represent that you're keying in single data only. Okay, and if you really want to key in single data over here, you need to key in 0, 0, 0, 0 for 47 times, and then after that, total you need to key in 300 different data, right? Which is a very, very troublesome thing. So therefore, we need to learn how to switch on our frequency. So using this calculator, okay, let me just clear my memory first. Alright, you go on to Shift, Set Up. Okay, then press down over to the next page. Go on to number 4, Stat. They will ask for frequency, whether for it to be on or off. Whenever you reset your calculator for this Casio version, right, the frequency will automatically turn on. Okay, so you need to remember how to turn it on. Okay, so once you turn it on, you follow the same series of steps again. That's how you do your ungrouped data. So mode, setup, sorry, not shift setup. You go on to setup itself, okay, then after select stat, one variance, and you will find that your table now has a second column. Okay? If you are using the Sharp calculator, I found this version, I hope it's the same version as those other students that I saw that you all have this calculator as well. Okay, let me give it a try. Never really tried this one before. Okay, for this Sharp version, right, what's easy is that when you clear your data, alpha memory, second function memory clear, reset 0. Okay, so you go on to your mode, stat SD0, you will automatically get this table. So for the Sharp calculator, this model, okay, it isn't an issue because the frequency column is already always given. Even if you key in ungrouped data, the frequency is automatically 1. Whereas for group data, okay, in this case, you will key in 0 as the data, press equal sign, you can shift your cursor over to frequency to change to 47. Likewise, in your Casio calculator, you key in 0, equal, go to frequency, change to 47. Okay, so could you all give it a try? Key in the data according to the table here. The value of A in this case, the A value should be 300 minus away all the other frequencies, 34. Let me just write it on the whiteboard. A is 34. Okay, so key in the data already. Let me do it on another calculator. 1, 2, 3, 4. Okay, so once you're done already, you go on to the main page. Okay, then on the Casio calculator, you press Shift Stat for variance to mean, get 1.79. On Sharp calculator, you press, where was the button before you say, oh, alpha number 8, number 2 variable, 1 mean, equal sign 1.79. Okay, can we all check that you get 1.79? Right? Please make sure you give it a try now. Okay, anybody not able to get? Amanda, you know how? Come here.
I couldn't even follow until here.
Data frequency. So, let's say the data is 0.7, right? 看 figure it out. Oh, ayo, why you never go on to us just now? What are you doing, Mass Jill? What's this? How do you clear it now? 2 reset 0. Okay, go to mode 1 step 0 SD. Just follows the instructions here. Exactly. Okay, so yeah, so number 3, right? At this page, you key in the data 0, press X1, 47 here. Okay, then you press change. This is not in the data. Okay, it must always be data come first, then frequency. Yeah. Then you have 1 comma in 1 page. Try next 3 sets. 2 comma 4 change. 3 comma 44 change. 4 comma 34. Okay. Then once you're done already, you go to alpha. We look for X bar, right? Because we're finding mean. So number 4 comma 7. Get it? Okay, so you maybe want to add it in. So that is common to pressing this XY or XY. Yes, I will say it. Alright, anybody still figuring out your calculator? Got to go and practice, yeah? Okay. Now, the working. Okay. When it comes to the working, okay, what you will do is that what you write as for what you did when you're in Set 2, okay, you write down the data times the frequency plus data times frequency. Okay, in this case actually it's just 5 data, you could afford to write it all. Otherwise, first 2 and last 2 or first 2 and last 1 is also fine. So 4 times 34. Divide by total of 300 equals to 1.79. Okay, so this will be the working that you should show. And knowing this formula as well, you could actually just verify that you or whatever you get in your calculator is correct. Okay. Any questions? Oh yes, sorry. Round off. Sorry? Because children cannot be. Alright? Good question. Okay. Joseph asking whether 1.79 need to round off or not, because number of children cannot be a decimal number. That makes sense. But then, okay, when it comes to mean and all that, we do not round off. We keep it to still 3SF. Reason is because we're talking about average. It can still make sense that instead of saying 1.79 children per family, I could always change the way I phrase it as 179 children every 100 family. You understand? Okay, so this can be interpreted in two ways. 1.79 children per family. Or if I were to multiply by 100, okay, 100 family would mean that there's 179 children for every 100 family. Okay, so then this may actually make much more sense because you're looking at whole numbers. Right, so don't need to go and round off. Okay, because data can actually be reinterpreted in the same mathematical sense. Okay, they are equivalent understanding. Okay. Questions? Alright. Next thing, okay, that I want to mention, what if, okay, in exam you really don't remember this formula. Either you refer to the formula list, okay, whereby the formula given will be in this format, which means that this letter E looking sign, right, that's what we call the sigma sign. It is the meaning of it is the addition meaning, okay? So we're taking a frequency times the data. F represents frequency, X is the data. So actually if I were to open it up, it really means this. Okay, so it's always frequency times data plus frequency times data divided by the total frequency, which is sum of frequency. Okay, so even if it is single data like this, it works because it is just data times 1 because frequency is 1. Right, so you could actually make use of the formula found in your formula list to remember this, and you could use then check whether your calculator value is it accurate or not. Okay, but what if, okay, worst come to worst, even if this formula given to you, you still don't understand the formula and you still don't know how to use it, then you can only rely on your calculator to give you the answer. There is nothing wrong, okay, if you present your final answer as mean equals to 1.79. But there is a danger, because the thing is, what if this is a 2-mark question? And this number, you got it from your calculator, okay, through using all the steps and all that. Then, after that, your calculator pressing is incorrect. Okay, so your answer mark surely is out already. Okay, then after, if you leave your answer in this manner, and this is a 2-mark question, so long as this number wrong, okay, 2 marks totally gone. You understand? Okay, but if you actually had this step, although this step and this answer end up is actually incorrect, they're not equal, at least you got this step, you still can get 1 method mark. You understand what I'm saying? Okay, so that's why to really play it safe, I really encourage you to write down this step and then after that get your final answer. Okay? Any questions? Okay, if not, then let's move on to another way of presenting group data. Okay, so we also have group data in this manner. Okay, whereby we are looking at it in the sense of 0 to 2. Okay, so they did not give you the individual data. So the weekly savings of a group of students are tabulated below. So it's all in a range. Then after that frequency is 5. So what we learned when we were in Set 2 in calculating the mean value for such information is that we need to find the mean value. Mean value is taken from the lower limit, lower boundary, and the upper boundary, add them up together, divide by 2. So you need to always create your mean value column. 0 plus 2 divided by 2 will give you 1. 2 plus 4 divided by 2 gives you 3. Then 5, 7, and 9. Okay, so this formula here is important. Why am I emphasizing on this? Because sometimes students actually just assume the mean value and end up is wrong. Okay, very commonly things like 0 to 1. Okay, answer should be 0.5 in the center. Somehow students can calculate it wrongly. Okay, so always just remember lower plus upper divided by 2. Okay. So in part A, we want to find the modal class. By class, we are referring to an interval. Okay. Please don't misinterpret to think that, oh, we're talking about students, and then you're talking about class 101, 102, and all that. That's not what it means. We're looking at interval. Okay, there is a mathematical meaning behind the word class. In this case, it is an interval itself. So the one with the highest frequency for mode, that will actually be this one here. So the highest, the modal class will actually be 6 to 8. Okay. Whereas for part B, the estimated mean weekly savings, giving your answer to correct to nearest cent. Alright, so we're looking for mean. What do we key in your calculator if our information is grouped in this manner? We key in our mean value here. Okay, so using your calculator, clear your memory. Okay, go back to the same series of steps. Okay, if you solely just clear memory, I also just found out, if you clear memory only, your frequency could still be on. But then if you are clearing all, it gets entirely reset out of the statistics mode already. Okay, so do try to understand your calculator. You may want to even consider having 2 different models for different functions. Okay. So in this case, we will key in 1 for the x value, the data value, 3, 5, and 7, and 9. Go to frequency column, 5, 15, 20, 25, and 10. Okay. Do the same corresponding sets for your calculator. Okay, then you should find that your mean should be about 5.53333. Just short one, they always ask for clear memory and control. So second function and clear one and but if the second function and clear, set 0. For the sharp calculator, right, as far as I remember, okay, somehow they always ask for memory reset to be shown before the start of the exam. Okay, that's something that I observed when invigilating O-levels last year. So they require that reset for sharp calculators. I don't know why KCU never expect lah, okay, but do make sure you know how to actually clear your memories. Okay, so can alright. Okay, so do you all get 5.53333? So in this case, working wise, this is an estimated mean. I'll explain later on why it's estimated. Okay, we actually took the mid value times the frequency, mid value times the frequency, and then we can dot 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 plus mid value times frequency. Total frequency will be 5 plus 15 plus 20 plus 25 plus 10. So even if you key this in your calculator by your usual manner, you will also get 5.53. Okay, but in this case, sorry, let me write forward. Okay, so take note that in your calculator, right? Okay, in this case you can still change it into fraction, but then we're talking about weekly savings. It is in money form. Okay, it doesn't make sense to give money in fractional form. And then also questions specifically say round off to nearest cent. Okay, so if the question has such a demand, make sure you change it into nearest cent. But in this case, for money, it's always nearest 1 cent anyway. Okay, so nearest 1 cent will be $5.53. Okay, so that should be your answer. Okay, so regarding the idea of estimator, okay, sometimes there are questions asking why is the mean estimated, okay, and can't be exact. Okay, so you need to understand why is it estimated. Could someone explain to me why is it estimated? Anybody has any ideas? Why is it estimated? No idea? Covered this before in Sec 2 actually. Okay, so the reason why this is estimated is because the data that we are taking is a mid value. Okay, so we are not taking the exact data, alright, for the frequency. We're not taking the exact, okay, weekly saving for each student that we're having in the calculation. We are just making an assumption over here by taking the mean value. So that's why the mean value over here can only be an estimated one. It cannot be an exact one. To get an exact one, we need to have the full information like what we saw in example 19 and 20. Understand? Okay, so to explain this question, I can say that it is because the data used in the calculation were the mid values of each interval class and not the exact data value of each student. at the inadequacy of mean, median, and mode before we talk about standard deviation. Okay, so when we talk about mean, median, and mode, alright, they are measures of average. Okay, there are cases whereby we can have two different sets of data, but the mean, median, and mode, they are all the same. Okay, but clearly the distribution of the data is different because this one has a wider range, this one has a range between 2 and 4 only, or rather a range of 2 and then a range of 4. Right? So that's the reason why we need to talk about, okay, the measure of spread. Okay, and one measure of spread that we have just learned is the interquartile range. And in the interquartile range, okay, it is about the median itself. We're looking at the middle 50% of the distribution. Right? So we usually use interquartile range when the median is a more appropriate measure of the average, and median is appropriate measure when there are extreme values. Okay, so when there are extreme values, using median will be more appropriate. Because when there is an extreme value, let's say for example, I gave you an example before actually I remember, many of you are getting very high marks, okay, then one person get maybe 2 marks only, okay, then it will affect the way we calculate mean value, right? I said this before, okay, so the mean value is easily affected by extreme values, or in fact maybe many of you get very poor results and then one person get 2 marks, okay, then it will not be a justified, okay, representative average when we talk about mean. Alright, so now we're going to talk about standard deviation, which is a way we measure spread as well when we use mean as a measure of average. Okay, so for standard deviation, it is slightly different from how interquartile range is arrived. Interquartile range is derived from the middle 50% of the distribution. Whereas for standard deviation, it is derived by looking at the spread about the mean. So let's say the mean, okay, if I were to draw a diagram to illustrate the idea, let's say the mean is here. Okay, standard deviation is like a radius, okay, around the mean. So this is the standard deviation. So we're looking at, for example, okay, I was just looking at your data for WA1, right? This is our breakdown, okay? In our next department, we do look at standard deviation, or when we do our result analysis, we have this column, okay? Our mean subject, mean mark, is 70.4, okay? So, this is percentage, we don't need to see highest and lowest, alright? So, with the mean being 70.4 and the standard deviation being 12, so that means that for many students, okay, they are actually in the radius of 70.4 plus or minus 12.05. You understand? They either fall 12.05 below 70.4 or 12.05 above 70.4. Okay, so you regard standard deviation like a radius around the mean. You get what I'm trying to say? Plus and minus. Okay? You understand? Okay, so that is a realistic set of data. Now, standard deviation, it can be calculated using this formula, although we will not be using the formula, okay, to do our calculations as much. Alright? Because it is a very tedious task. So we usually use our calculator to do the calculation. So in my calculator steps that are given to you, okay, all these sigma x, they actually represent standard deviation. Okay, so now let's practice the calculator skill. So in this case, you're given a standard dev diagram as well as the mean and standard deviation for team Y, okay? For team X, we want to calculate the mean. So in this case, the data that we need to key in is 82, 86, 87, right? So could I give you just 1 minute, key in all this data into your calculator, tell me what is the mean first, okay? memory before whenever you start a new set of data. Okay, I hope all of us are able to get about 97.4. Okay, we do the mean first, alright? You can always keep your frequency on for those Casio calculators. Okay? Just that your frequency will all be ones. Yes.
But for standard deviation, but then, right? But you see standard deviation of the different formulas. So you must know what is the value of first you need to know what is the sum of frequency and x squared. That will not be the same answer. And then there are also this one. So there's many different formulas. But this one is what is the formula. So I don't usually the formula. And in case Okay, so I'll come back now. Right, everyone able to get this? Okay. So mean-wise, so if let's say you don't want to write the working and you're very confident your answer is correct, we should get 97.4. Okay, you should round it to 3SF. But then if you want to write the working, your working should be presented at least first two and the last one. Okay.
So last one in the data is 115. Divide by 22 members, we will get 97.4 3SM. Now for standard deviation, okay, so you no need to key in the data again. Go to the stat, find your standard deviation, sigma x, this one, number 3, 3, okay, you should get 9.49. When it comes to standard deviation, okay, there isn't really a working for it. Okay, so you can write your 5SF value. You get 9.49. Okay. So standard deviation, no working required, just put 9.49. So that's why the calculator pressing, but you must be very confident in it. Okay? Now, what if you want to use the formula? Okay? There is a formula being provided. Okay? But when it comes to standard deviation, very often, the formula that is used by different groups of scientists, okay, could be rather different. Okay, but we all call them standard deviation. So we have this type of formula and this type of formula. In your formula list, what you will see is this formula. Okay, this formula actually means the same thing as this one over here. Okay, because sum of fx over sum of f is your mean. So it is the same as x bar squared. Okay, I don't really encourage you using the formula to calculate because it can be very complicated and very not easy to get these values up. Okay, so usually for standard deviation, just press calculator. Okay, and standard deviation, as far as we were told, it's usually a 1 mark question, so no working mark will be given. Okay, so 9.49. Just press calculator accurately. Yes. No. Yeah, because that was one that's conveyed to us from Cambridge now. Okay. Even if 2 marks, you can just write this one. You get straightforward 2 marks. Okay, so press calculator correctly. Okay. Questions? Next one, part B. Okay, which team performed better and why? So let me just put the summary here. Okay, if you were to compare these two data side by side, we see that the mean for team Y is higher, the mean for team X is lower. Standard deviation for team Y is 7.8, for team X is 9.49. What we can interpret from this is that for team X itself, the standard deviation being 9.49 being wider, it means that there is lesser consistency towards the mean. So this time we're talking about the scores in the math quiz. Okay, so that means that with the mean at 97.4, there is a wider spread of marks, 9.49 wider, okay, spread of marks around the mean itself. Whereas for this one, 98.5, mean is higher, and furthermore, the standard deviation is smaller. So people's marks tend to be closer to 98.5, whereas over here is further away from 97.4. Okay, so when we want to address about the performance, we could talk about the mean, okay, to actually do the comparison in general. Okay, so we will say that team Y performed better. It is because the mean score of team Y is higher. than that of team X. Okay? If you really want to support it further, you can talk about the standard deviation. So furthermore, the standard deviation of team Y is smaller than that of team X. Thus, the scores of team Y are more consistent around the mean than that of team X. Okay, questions? Okay, for exercise 3C homework that's found on page 20 of your notes,